Light gathering power of an optical device is the ratio of the image illumination generated by the given system to the brightness of the rendered object. If we assume in a particular case that object brightness is a constant value, then the object's illuminance will be a parameter which determines light gathering power of the optical system. When image is examined by a human's eye, then there is a subjectivity factor in the assessment of its illuminance. In this case, a photic stimulation occurs in the eye. Its psychophysiological perception is called a subjective brightness. If the image is registered by a light-sensitive photographic layer or surface of the optoelectronic or other light detector, then its illuminance is assessed objectively and can be expressed in luxes. The ratio of entrance pupil's diameter d to the focal distance f is called aperture ratio. The square of aperture ratio is called a geometric aperture ratio. The product of light transmission factor times geometric aperture ratio is called the physical aperture ratio. When light flux passes through the lens, then part of it is absorbed by the mass of the glass. Another part is reflected and dissipated by the lens surface. That is why a light flux reaches a light-sensitive element in a reduced state. A light gathering power which considers these losses is called effective. On average, when non-coated objective lenses have light passing through the lens, then light flux is reduced by 1% per centimeter of glass thickness and by 5% of raised reflection on each surface of a glass section. A lens barrel, for example, that of a photocamera, usually has numbers inverse to the aperture ratio. For example, 1, 1.4, 2, 2.8, and so on. Illuminance at transition from one number to another, and therefore light gathering power, increases by 2 times.